Hi students, myself Hariharan. I am working in Pearls Academy for the past 3 years and I have 8 years of experience in this field. As a chemistry faculty, I am going to start with chemical bonding and I am going to give you some tricks and shortcuts to find out the hybridization and the bond angle and bond order and etc. We will see the class, hear it. Hi students, today we are going to see about hybridization. So we all know what is hybridization is. Hybridization, the name itself, it is showing that mixing of something. Here what we are going to mix is nothing but, in an atom we have so many type of orbitals. So we have S, P, D, F. So these kind of orbitals are being in an atomic orbital, but we have to get the more stable form of orbitals. So to attain the stability, the orbital is going to intermix with each other and they will produce a new kind of orbitals, which is nothing but the intermixing of orbital is called hybridization. The new type of orbital which is produced during the hybridization is called hybridized orbital. The hybridized orbital is more stable than the atomic orbitals. So we know that the hybridizations like sp and sp2 and the sp3 and sp3d and also and etc. We have so many kind of hybridizations. So what is mean by sp hybridized orbital? What is mean by sp hybridization? Sp hybridization is nothing but, in an atom we have s orbital and p orbital. When we mix a single s orbital with a single p orbital, we will get sp orbital. That's it, that's all. So we are taking one s orbital and we are taking one p orbital. When we mix these two orbital, we will get two new sp hybridized orbital. So in this way we have to understand. Then we will see what is sp2. It's nothing but, we are taking one s orbital and what is p2? Two p orbitals. I am involving three orbitals. I am involving the three orbitals in hybridization. So what I am going to get in the end is, I am going to get 3 sp2 hybridized orbital. The same here, sp3 means what? 1 s orbital and 3 p orbital. So what I am going to get? I am going to get 4 new sp3 hybridized orbital. Likewise it is going on. So this is what the basic hybridization is. We will see in detail in the following lectures. So now what we are going to see is how to find the hybridization and what are the tricks are there, what are the shortcuts are there, what are the simplest way to find the hybridization. This is all we are going to see. So we will go to the finding out section. So how to find the hybridization? The basic principle is, hybridization is nothing but, it is the addition of number of lone pairs and sigma bonds. Just we are going to calculate how many sigma bonds are there and how many lone pairs are there in a given compound. Just take an example. We will take beryllium chloride. So you know well about beryllium chloride, where beryllium is a central atom. So what is the meaning of central atom and how to find the central atom? Central atom is nothing but, in a compound, if any atom is present in a lower amount, lesser amount, that is called central atom and it should make multiple bonds. So in this case, beryllium chloride, we have few beryllium and more chlorine atom. So in roughly we can find out beryllium can be the central atom, and how we can make the decisions right is nothing but, beryllium can make 2 bonds and chlorine normally can make 1 bond, single bond. So we will take beryllium as a central atom. For the central atom only we have to see the electronic configuration. So for beryllium the atomic number is 4 and the electronic configuration is 1s2 and 2s2. So we are going to take the outermost shell electrons. Outermost shell electrons means what? Here in beryllium we have first shell and second shell. Which one will be the outermost one? The second shell. How many electrons are there? So totally 2 electrons are there. Just we are going to take the 2 electrons alone. Why we are taking the 2 electrons? Just we have 4 electrons, but why I am taking only the 2 electrons is, these 2 electrons only will participate in bonding. Okay, so we very well know that the outermost electron only will take part in a chemical process, chemical bonding process. No other electrons will involve in this. So I am taking these two electrons, and what is the element is going to attach with this chlorine. So we know about chlorine. Chlorine usually make a single bond. In normal times, the chlorine will always make a single bond. In some cases it will make 3 bonds, 4 bonds, 5 bonds and 6, 7 bonds and etc. We will see those things in later stages. So as of now, normally chlorine makes a single bond. So now here this electron belongs to beryllium. So chlorine is taking one of its electron and it is making a bond, and another chlorine is coming and taking another electron from the beryllium. So initially we have 2 electron in its outermost shell, and those 2 electrons were taken by chlorine. So the bond all happened. Now what I am going to do is, I am going to check whether the beryllium is having a lone pair or not. So how we can find the beryllium having lone pair or not? Just calculate. Beryllium having outermost electron 2, outer shell they have only 2 electrons. So these 2 electrons were bonded. So no other electrons are left behind. So there is no lone pair. First of all, how many lone pairs are there means there is no lone pair, because beryllium having only 2 electrons in outermost shell, and that 2 electron also bonded. So there is no electron left behind. So there is no lone pair. And how many sigma bonds are there? So beryllium making a single bond with one chlorine, so it must be sigma, and beryllium is making another bond with another chlorine, then that also must be a sigma bond. So totally we have 2 sigma bonds. Okay, so finally we are adding both the things. Hybridization is equal to number of lone pairs plus number of sigma bonds. So we have 0 lone pair and we have 2 sigma bond. So hybridization is 2. We are converting these 2 into sp3d form, spdf form. So I am writing sp, we have 2, s1, p1, that's it. So finally we can write it as sp hybridization. It's very simple. You just need to check how many lone pairs are present in the central atom and how many sigma bond it is making, and then we can easily convert that value into sp hybridization and like that. Okay, so this is one of the first example. We will see the another example and we will see one by one. So first we will see the next example. I am taking NH3. First what I am going to do is, I am going to find the number of valence electrons in its outermost shell. So nitrogen atomic number is 7 and the electronic configuration is 1s2, 2s2, 2p3. What is the outermost shell is second shell. We have 2 shells, first shell and second shell. Which is going to be the outermost one? Second shell. How many electrons are there? Totally 5 electrons. I am writing 5 electrons as like this. Okay, so what atom is going to attach with the nitrogen is hydrogen. So we will discuss about hydrogen. Commonly hydrogen makes how many bonds? Hydrogen makes a single bond. So here also it is taking one of the electron from nitrogen. It is nitrogen's electrons. It is taking one of the nitrogen electron to bond with hydrogen. Another electron from nitrogen is bonded with hydrogen. Another electron from nitrogen is bonded with hydrogen. So totally we have 3 hydrogens. 3 hydrogens were bonded. Now I am looking to nitrogen. I have to find whether the nitrogen is having extra electrons other than bonded electrons. These 3 electrons were bonded. Other than that, I have one pair of electron in nitrogen shell. So this pair of electron is called as lone pair. So finally I found that one lone pair is present in the nitrogen in the NH3 compound. And how many sigma bonds are there? This one sigma bond and this one and this one. So totally we have 3 sigma bonds and 1 lone pair. So hybridization is nothing but the addition of these 2 only. Lone pairs are 1 and sigma bonds are 3. So totally 4. 4 means S1 P3. Why we cannot fill 2, 3 in S? So in S orbital it is having only 1 box. So we can use only 1. But in P we have 3 boxes. So we can write up to 3. For D orbital we can write up to what? 5. In F orbital we can write up to 7. But that is a very rare case. But we will see as of now in NH3, so initially we will see one by one. In initially NH3 are having a 5 outermost electron, and I am representing these 5 outermost electron like this, and one of the electron is bonded with hydrogen, and one of the electron is bonded with another hydrogen, and one of the electron is bonded with another hydrogen. So we have 3 different hydrogens. 3 different hydrogens were bonded to nitrogen. So that's all the bonding happened, and I am checking whether I am having extra electron in nitrogen atom. So apart from these 3 bonding, I am having a pair of electron in its outermost shell. So pair of electron present in the outermost shell which is not involved in bonding is called as lone pair. So I have one lone pair and 3 sigma bonds. Just I am adding these two, one lone pair and 3 sigma bond. So this is what I get, the 4. The 4 value can be represented by S1 and P3, because I cannot substitute all the values on the S itself, because I should the S orbital is having only one box. So P orbital is having only 3 boxes. So I have to fill accordingly. So I am filling S1 and P3. So finally I can write it as sp3 hybridization, which is tetrahedral in geometry, and the structure of this NH3 will be trigonal pyramidal. We will see the structures in later stages. So in this way we can find the hybridization. Now you can ask whether we can find the hybridization like this for the ionic compounds. Yes sir, we can find this kind of hybridization for ionic compounds, ions. So we will see one of the ion to find the hybridization. So you know what NH4 is, an ammonium ion. We will see the hybridization for NH4, and as well as we can see the hybridization for H3O plus also. It's very easy. Just you have to follow one strict rule, nothing but you have to find the valence electrons, and you just bond that electrons and find out the lone pair and find out the sigma bond. That's it. So nitrogen, initially we know that nitrogen is having 5 electron in its outermost shell, but here we are having plus charge. What is mean by plus charge? Plus charge means one of its electron is lost. One of the electron is lost. So among these 5 electrons, 1 electron lost. So 1 electron we should not consider. So now we are having only 4 electron in its outermost shell. So I am bonding each electron to each hydrogen. Okay, I am having 4 hydrogen. So 4 hydrogen were bonded to 4 different electrons from nitrogen. So the bonding has been completed, and I am checking whether I am having extra pair of electrons. There is no pair of electron apart from these 5, 4, because the 5th electron got lost. Okay, so I am going to calculate number of sigma bonds and lone pairs. So lone pair is 0, because I am having only 4 electron. 4 electron were bonded, so no more electron. So lone pair is 0. And how many sigma bonds are there? As we see here, this one, this one, this one, this one. So 4 sigma bonds. So 4 plus 0, it is 4. 4 means S1 P3, which is nothing but sp3 hybridization. That's it. Now we will see H3O plus. As usual, we will start from the oxygen. Here you can easily find who is central atom. Nothing, oxygen is a central atom. So oxygen, how many valence electrons were there? So oxygen are usually having 6 valence electrons. So I am representing all the 6 valence electrons like this: 1, 2, 3, 4, 5, 6. So what is meant by plus? As I said earlier, plus means 1 electron is lost. So I am taking out one of the electron. So now it is having only 5 electron. Among these 5 electron, I am going to add each electron to each hydrogen. I have 3 hydrogen, so I am going to bond with 3 hydrogens. Now I am checking whether I am having a lone pair or not. So you just see that from the picture itself, it is showing that one of the pair of electron is left behind. So it is having one lone pair. So what is the formula for hybridization? So hybridization is nothing but sigma bond plus lone pair. I have one lone pair, and how many sigma bonds are there? Totally 3 sigma bonds are there. In total it is 4. 4 means S1 P3, which is nothing but sp3. This is how you have to calculate for the ionic compounds. It's very easy and efficient method. Once you practice these things more than 20-30 times, 20-30 compounds, you can easily calculate in the mind itself. So it is very easy to find out. So try this method to find the hybridization. We'll see the tricks to find bond order and tricks to find the magnetism in upcoming slides. Okay, now we will see the bond order trick. So it is very easy and it is so interesting. So we will see one by one. We know nitrogen molecule. So in nitrogen molecule, how many electrons are there? 14 electrons. Each nitrogen 7 electrons. So in total nitrogen is having 14 electrons. We all know that, and we also know that nitrogen molecule we have three bonds, which is a triple bond. We know it is very simple and it is basic one. So in nitrogen molecule we have triple bond. So the bond order is 3. We all know that. So if we know these things, we can easily able to find the other species bond order. We'll see one by one. What you are going to do is, you just write in a ascending and descending manner 13, 12, 11 and 10. Below that it will be 15, 16, 17 and 18. And bond order you just write it decreased by 0.5 and increased and also both sides you just decreased by 0.5. So if we decrease by 0.5, we will get 2.5, and this one will be 2 and this one will be 1.5 and this one will be 1. Likewise you just do here itself. Okay, so we know 14 electrons, if any species is having, it is going to have the bond order 3. And what is the bond order of O2 plus? So by using this trick we can easily find out. So we know that O2 molecule, how many electrons are there? Oxygen is having 8 electron and another is oxygen is having 8 electron, and if we add both the things we are going to get 16 electrons. So 16 electrons is there in O2 molecule. Here what we are getting, O2 plus. O2 plus means what? As I said earlier, plus means a loss of electron. How many plus are there? Only one plus is there, which means one electron lost. So from 16 electron, one electron lost, so it is getting 15 electrons in its shells. So here for 15, what is the bond order? It is 2.3. Just you can write this O2 plus will get 2.5 as a bond order. That's it. Very simple. If they are giving you N2 2 minus, the same procedure. You just find the electrons present in nitrogen first of all. So if you take a neutral nitrogen molecule, it is going to have 14 electron in its shell, and 2 minus means what? Plus means lost, minus means gained. How many electron is gained? 2 electrons are gained. So plus 2 electrons, so it is getting 16 electrons. So O2 2 minus is going to have 16 electrons in its outermost shell and its shells. Okay, not the outermost, the total shell. The total number of electron is 16. So for the 16, the value is 2. So the N2 2 minus value is going to be 2. This is how you can find the bond order of each and every molecules as a diatomic. So we'll see a few more examples like this. O2 2 minus, O2 2 plus, N2 2 plus, CO, Cn minus, like this it will go on. So we'll see one by one. O2 means 16 electron, 2 minus mean 2 electron is gained. So 16 plus 2, 18. Here O2 2 plus, O2 means 16 electrons, 2 plus means 2 electrons were lost, so it is 14 electron it is having. Next nitrogen. Nitrogen usually have 14 electron in its outermost shell, which means in total nitrogen is having 14 electrons. 2 plus means 2 electrons lost, so totally we will get 12 electrons. Then carbon monoxide. We know carbon having 6 electron and oxygen is having 8 electrons. 6 plus 18 will be 14. And Cn minus, carbon 6, nitrogen 7, 6 plus 7, 13, 13 minus means 13 plus 1, so 14. So 14 means bond order 3, here 14 means bond order 3, 12 means 2, 14 means 3, 18 means 1. Here you can compare these two. So this is how we can find the bond order for these kind of diatomic molecules. So this is all about bond order, and we will see the magnetism, paramagnetism and diamagnetism. That's the next case. They can ask you what is the magnetism of O2 2 minus, or they can ask you what is magnetism of O2 2 plus, like that they can ask. So we have two kind of magnetism. One is paramagnetic another one is diamagnetic. Either the molecule can be paramagnetic or it can be diamagnetic. So how we can find the species as paramagnetic or diamagnetic? It is very simple. Paramagnetic means that should contain odd number of electrons. Diamagnetic means that should contain even number of electrons. Only 10 and 16 were the exceptions in diamagnetism, which means if you are going to get the 10 or 16, you should not choose as a diamagnetic, it will be the paramagnetic. Clear? So we'll see one by one. O2 2 minus, how many electrons were there? Total number of electrons. Each oxygen is going to have 8 electrons. So 8 plus 8 normally 16. 2 minus means 2 electrons gained, totally 18 electron. 18 it will be comes under even number. So even number means it is diamagnetic. Is it clear? So O2 2 minus is diamagnetic. We'll come to O2 2 plus. So usually how many electrons were there in O2? O2 usually 16 electron, and 2 plus means what? 2 plus means 2 electron lost. 2 electron lost means 14 electrons. 14 electrons, 14 is a even number, so it is also diamagnetic. O2 also diamagnetic. And what is O2 plus? We'll take O2 plus. O2 plus is nothing but usually the O2 molecule is going to have 16 electron. Plus means 1 electron lost, so it is 15, which is odd number, and it is a paramagnetic. Okay, O2, simply O2. O2 having 16 electron in its outer in its total. Okay, so total number of electron present in an O2 molecule is 16. So 16 is an even number, but 16 and 10 are exceptions. Even though you get an even number, you should not say this molecule as a diamagnetic. It is a paramagnetic. That is what the exceptions in this trick. So these two tricks were very useful in order to find the bond order and magnetism. So this is all about the class.